All right, we're going to be doing a similar example as we did in example 8, and that is we want to find equation of a line that models the data that we have here. So let's see what we got. The number of post offices in the United States is shown on the graph. So this is each year, 2003 to 2008. And by the thousands over here, this is how many post offices were in the United States. United States Post Office Services source. Voila. So we want to use information given for the years 2003 and 2008, letting x equals 3 to represent 2003. So really this is like x equals 3. And x equals 8 to represent 2008. So really this is 3, 4, 5, 6, 7, and 8. All right. And y represents the number of post offices. So here are the number of post offices. And we want to write an equation that models the data. Can we create some kind of line where we have 1 point right here, right? Because if this is the point 3, 27,555, so that's like 1 point right there. And this is the point 8, 27,023.2, so that's another point right there. I can go ahead and connect those 2 points, right? And that's going to give me some kind of a line. All right, and that's going to, I mean, it kind of looks like it's going to match it exactly though, but some of these little bar graphs may be slightly below, or so we'll see what happens here, okay? So we have 2 coordinate points right now, and those two coordinate points are 3, right? This coordinate point 3, and the y value is 27,556, and the other coordinate point is 8, 27,232. All right. We want to find the equation of a line. So again, what we're going to do is that we want to put it in slope-intercept form. So we need an m and we need a b. So let's first start with finding the m. Okay, so I'm going to subtract the y coordinates. Okay. And it doesn't matter, you know, if I do it from left to right or right to left. I'll just go from here. So I'll do 27,232 minus 27,556, and we're going to subtract that from 8 minus 3. All right, if you do that right there, then we'll get, let's see, a negative 324 on top. We'll get 5, and so we want to have a nice decimal here. We get negative 64.8. Okay, that would be our slope. Now, notice that it's a negative slope, which means it started higher over here in 2003, and then it got lower. It went lower. 20. I mean, even if you look at the numbers here, 556, 232, it obviously went lower. So that's why we should have a lower slope. You really can't see it here, but really this line, this slope, is actually declining. From left to right, it's going down. All right, so now that we have the m, we're halfway there. Y equals negative 64.8x plus b. Okay, so I'm trying to write this in slope-intercept form. So now I need to find the y-intercept. Now the way that we can find the y-intercept is we choose one of these points. It doesn't matter which one. I'm just gonna choose this guy right here. I mean, it doesn't matter which one here. So 3 will replace the x, and the 27,556 will replace the y. Okay, so the x coordinate goes with the x, and the y coordinate goes with the y. All right, so we plug it in, and again, if you wanted to use the second point, you could do that, and we will get the same answer. So let's replace y. So 27,556 equals negative 64.8 times x, which is 3, plus b. Do a little bit of math here. 27,556, that will equal negative 194.4 plus b. Now we'll go ahead and add 194.4 on both sides. So we'll get that guy going. So then we'll have b equals 27,000 750.4. So we have our M, we have our B. So now the equation for part A now, y equals mx plus b. So my M and then plus my B, 27,750.4. All right, so this equation will model this data right here. Now, part B. What's going on with part B now? Part B, we're asked, okay, so now use the equation that we found in part A to approximate the number of post offices in 2006. So, because they don't tell us, I mean, we can eyeball it, but we don't know, exactly how many numbers, so we can use this data or this equation to approximate it there, all right? So if we're trying to figure out what happens in 2006, that's the same thing as x equals 6, right? So that's when x equals 6. So let's replace x with 6. So negative 64.8 times 6 plus 27,750.4. And doing all that, we would get 27,361.6. And how does the result compare with the actual value? Well, this is 27,361. This is 27,318. So obviously this is bigger. And actually that does make sense because it looks like our line is slightly bigger than it. And if I zoom in right here at the 6, or if I zoom in really, really close right there, the line, this line right here is slightly above where this is right here. I mean, maybe if I made my line a little thinner, that probably would have worked even better. But so because we have a negative slope, is slightly below it, so this is bigger right here.